Let's take a look at acid-base neutralization reactions. Sometimes we call these water-forming reactions. When an acid and a base are combined, a neutralization reaction occurs. The resulting solution has a pH closer to 7. Remember, low pHs are acidic, high pHs are basic. The products are water and an ionic compound. Acid, starting with an H, HNO3, aqueous, that means it's dissolved in water, plus NaOH, that's sodium hydroxide, aqueous dissolved in water, will give us H2O, a liquid, and NaNO3, another, that is an ionic compound. I just simply say salts. So acid plus base gives us water and a salt. Often we get a lot of energy out of an acid-base reaction. Generally, you're not supposed to do acid-base reactions unless they're very controlled. You can quickly overwhelm a sink with gases that form, because sometimes gases form when you do this, like carbon dioxide. All right, so what we're going to do is we're going to create these reactions and predict the outcomes and balance them. So iron 3 hydroxide. Iron 3 hydroxide, well, it's iron, and it's a 3 plus charge, and hydroxide is a 1 negative charge. So we're going to need 3 hydroxides. And that's going to be aqueous plus nitric acid. That's going to be an H. And then this is a Rule 2 acid, so it's going to be nitrate. So you go to your periodic table of ions. Your nitrate is NO3 negative, right there. And H is a 1 positive, so NO3. So you have 1 positive, 1 negative, balanced. Now what will that give us? Well, that will give us a water with the H and the OH together. Sorry, this guy's going to be aqueous as well, dissolved in water. We're going to get an HOH. And I'm leaving it as OH right now, and that's going to be a liquid. And then we're going to get FeNO3. Fe, and that's a 3 plus charge. So our NO3, we're going to need 3 of them to make it ionically balanced. There's our acid-base neutralization reaction. So now we need to balance this using the big numbers. Fe's are good. OHs, 3 OHs, 1 OH. Right? We want to treat the OHs as one thing. So we need 3 of these guys. H's, 1 H, now we have 3 H's here, so we get 3 here. Now we have 3 NO3s, and we have 3 NO3s, so we are now balanced, 1, 3, 3, 1. It's simple enough. It's just practicing naming acids, naming bases. Next one, magnesium hydroxide. So magnesium is Mg, and that's a 2 plus charge. So hydroxide has a 1 plus charge, so we need 2 of them. That's going to be aqueous. Plus sulfuric acid. That's a Rule 2, so that's going to be sulfate. So we go here, we look for sulfate, SO4, 2 negative. So we got an H at the start, and that's a 1 plus, and SO4, this is a 2 negative, so we need 2 hydrogens there. And that's going to be aqueous. Then that's going to give us, as a result, our magnesium is going to go with our SO4. Now magnesium is a 2 plus, and our SO4 is a 2 minus, so it just works out, MgSO4. And that's probably going to be aqueous. And our HOH. That's our water. We leave it as HOH, and that's going to be a liquid. So we can deal with the hydrogens and the hydroxides separately. Now we balance it. 1 Mg, 1 Mg. 2 OHs, 1 OH. We need 2 there. 2 H's, 2 H's. 1 SO4, 1 SO4. 1, 1, 1. Done. All right. Nickel 2 hydroxide and perchloric acid. So let's look up nickel 2 hydroxide. Nickel is Ni, and this 2 tells it has a plus 2 charge on it, and hydroxide has a minus 1 charge. So we're going to need 2 hydroxides here. right? Nickel's a 2 plus charge. This is a 1 minus, so to get them to balance. And that's going to be aqueous plus perchloric. This is a Rule 2 acid. We're looking for perchlorate. So we go here and we look for perchlorate. And we see if we have perchlorate on here. And we don't. We have chlorate, but we don't have perchlorate. I'm just going to do a quick check here to see if they're the same thing. So, perchlorate. Perchlorate is not quite the same as that. It is ClO4. Perchlorate is ClO4. So, and it has a -1 charge on it. So we're going to do hydrogen 1 plus ClO4. That's a 1 minus, so that's balanced. That's going to be aqueous. So what are we going to get? We're going to get our nickel's going to go with our perchlorate. So Ni is going to go with our ClO4. And we're going to need 2 of these ClO4s to balance the nickel 2. We're going to get HOH. This is a liquid. This is aqueous. Now we can balance them out. 1 Ni, 1 Ni, 2 OHs, 1 OH. Put a 2 here. 1 H, 2 H's. Put a 2 here. 2 ClO4s, 2 ClO4s. Everything's balanced. 1, 2, 1, 2. All right. So that's how you do acid-base reactions. You take your base, you take your acid, write them out. You're going to do a double displacement reaction where you're going to get a ionic substance and water. We leave the water in HOH form because it makes it easier to balance. All right, so just at the bottom, you got balance and classify each of the following as to type. I don't know what the heck as to type means. Whatever. So you're just going to balance them and then type them out. H2 plus Cl2 gives us HCl. Well, we got 2 H's, 1 H, so we're going to need 2 here. Now we got 2 Cl's, 2 Cl's, 1, 1, 2. That's synthesis. It's coming together. Ca and H2O gives us CaOH2 and H2. Notice somebody forgot to make these numbers small. We're just going to pretend that they are. I don't like H2O here. I'm going to put HOH. 1 Ca, 1 Ca. 1 OH, 2 OH. So we're going to need a 2 there. 2 H's, 2 H's. So it's going to be 1, 1, 1, 1, 2, 1, 2. The Ca replaces this H. The Ca replaces this H. This is a single replacement reaction. All right, 2KClO3 gives us 2 KCl's and 3 O2s. Well, that's already balanced for you. So I don't really know. And that's just a decomposition reaction. One thing becomes many things. Next one, we've got FeS and HCl. It's already balanced again. Don't know what I was thinking when I made this page. But our Fe switched up with the H, right? So our Fe now is with the Cl, and our H is now with the S. So this is a double displacement. Duple. Sounds kind of Scandinavian. Duple displacement. I don't know how to make it be like that, I think. Last one, Zn plus HCl. Well, we can check on the activity series to see if the Zn will replace the H. This is zinc and hydrochloric acid. From my experience, the H gets replaced. So you're going to get ZnCl. Now Cl is a 1 minus and zinc is a 2 plus, so it's going to be ZnCl2, zinc chloride, and H2. That's going to be a gas. This is a single replacement reaction, and we actually have to balance this one. Okay, so what do? 1 zinc, 1 zinc, 1 H, 2 H's. So we need 2 of these guys, 2 Cl's, balanced 1, 1, 1. All right, that's it. Remember how to do an acid-base neutralization reaction, what the products are from what the reactants are.